Hi everyone, this video is going to go over everything on notes pages 13 and 14 in your Unit 1 packet. On page 13, the top part, we could have a lot of different answers here. It says each of the equations below have been left with blanks. Fill in the blanks with a number that will make the equation true. The number you pick for the blank must be the same in each blank of that problem. Basically with this, I'm just going to go through and put an example of an answer that would apply to each problem. But remember, with these, you could come up with different things that would also be true. So if you've already filled this in, it doesn't necessarily mean that you need to erase and change anything. For the first one, this is 2 multiplied by something equals -10. You could treat this like a one-step equation if you wanted to, where we use maybe an x to represent the blank, and you could solve it. In this case, I would divide both sides by 2 and get that there is only one possible answer here. It has to be a -5. For B, you could pick any number here. So I'm going to go with maybe a 2. Again, this part doesn't matter. And notice that on the left, 5 multiplied by 2 equals 10. And when I do that on the right, 5 multiplied by 2 equals 10. Again, any number here would have made that true. For C, I'm going to go with 2 again, just to keep it simple. On the left, 3 plus 2 is 5. On the right, 5 plus 2 is 7. That doesn't work. I could try something different, but what I'm going to find here is no matter what I choose to plug in for those blank spots, I'm going to end up getting 2 different values on either side of my equal sign. For D, and you could pick anything for consistency. I'm just going to go with 2 again. On the left, 12 plus 2 equals 14. On the right, 12 plus 2 equals 14. For E, again, picking any number, I'm going to go with 2. On the left, 2 minus 2 is 0. On the right, 2 plus 2 is 4. That doesn't work. But this is another situation where no matter what I try here, I'm not going to get values that match. For F, 15 plus something equals 25. In this case, this has just one possible answer, and it's a 10. So it says to record your findings or anything interesting that you discovered in problems A through F. And hopefully what you started to notice is that some of these problems, like A and F, have just one possible solution, right? There's one thing that will work, and that's the only thing that will work. So one solution. For problems like, let's see, B or D, these have infinitely many solutions. We could test all sorts of things here, and we would have answers that match on both sides of the equal sign. The last one that we're looking at would be examples like C and E. For C and E, no matter what we try, there's just not going to be anything that works out. So with those, there would be no solution. For the chart below, on the left of the first one, this is saying that one solution is a possible type of answer that we would come across. It's the only type that we've looked at so far. In this type of equation, only one number will work to make the equation true. And again, where it says examples, I would just refer to things like A and F from above. For the second one, no solution. or in this case you could use maybe the null symbol. In this type of equation, there is not a number that will make the equation true. So going back up to the top, an example like C or E, where no matter what you plug in, nothing's going to work out. The last one is all real numbers or infinitely many, or the infinity symbol. In this type of equation, any number will work to make the equation true. So scenarios like B and D from above, where no matter what you plug in, you're going to get something that works. All right, let's take a look at the examples on page 14, and then we'll go from there. Number one, notice with this one that there are variables on both sides. So just like the notes from yesterday, we want to start by getting all the variables on the same side first. I'm going to move my variables over to the left side. And again, if it helps, you can draw a fence just to keep things separate. Just depends on how organized your numbers are. So I want to start by moving the negative 5x to the other side of the equal sign by adding it. Do that to both sides to keep it balanced. On the left, the negative 5x and the positive 5x will cancel, leaving me just with a 13. On the right, negative 5x and positive 5x will cancel, leaving me just with 13. In this situation, since the variables canceled each other out completely, so there is no variable left here, and the two sides of the equal sign are equivalent, this is an example of an equation that has infinitely many solutions. For number two, very first thing I see here are the grouping symbols on the left. So I want to start by distributing that 7 to get rid of them. So 7 multiplied by 2x would be 14x. 7 multiplied by negative 1 would be negative 7. On the right, there are some like terms that we could go ahead and combine. I'm seeing a 1 and a negative 8. So if I combine these together, I'm left with 14x minus 7. What I want to do from here is, again, move all my variables to one side of the equal symbol. I'm going to move all of them over to the left, just for consistency. Remember from yesterday, you could move it to either side. So to move the 14x, I'm going to subtract it, and I'm going to do that on both sides to keep things balanced. On the left, 14x minus 14x would cancel. I'm left with negative 7. On the right, 14x minus 14x would cancel, and I'm left with negative 7. This is the same scenario that happened in number 1. The variables are completely canceled out. They're gone. I'm left with two sides of the equal sign that really are equivalent. So this has infinitely many solutions. So no matter what we try for x, it'll be true on the left and right side of the equal sign. For number 3, I see grouping symbols first, so we want to go ahead and distribute. The 13 is going to come down and just kind of hang out while we distribute 2 to x, and that'll give us 2x. And then we're going to distribute 2 to negative 6, and that's going to put us at negative 12. On the left, I also see now a couple of like terms that I can put together. So we're going to combine 13 and negative 12. That's going to leave us at 1. So we have 2x plus 1 on the left. From here, I have equation with variables on both sides. So I'm going to go ahead and move all my variables over to the left side, again, just for consistency. Remember, you can move it to either side. To move my 4x over, I'm going to subtract it. On the left, this would put me at negative 2x plus 1, and on the right, just a negative 7. Now we have a two-step equation. So I'm going to move the 1 by subtracting it on both sides. That's going to leave me at negative 2x equals negative 8. And the last step would be to divide both sides by negative 2. So this one ends up having a single answer of 4. So this is a one solution equation. The only thing that will work is a positive 4. Okay, for number 4, see grouping symbols first. I'm going to distribute the 1/4. 1/4 multiplied by 8 will put me at 2. And that's 2x. 1/4 distributed to 4 puts me at a positive 1. I have variables on both sides of the equal sign. I'm going to move all the variables to the left. So I'm going to subtract 2x from the right side and do that to the left side. On the left, 2x minus 2x cancel, and I'm left with just a 1. On the right side, 2x minus 2x cancel, and I'm left with a negative 4. This is an example where the variables completely cancel out. The two sides of the equal sign are not equivalent, which means that there are no solutions for this problem. For number 5, I'm going to distribute the 1/2 first. 1/2 distributed to 6 would put us at a positive 3. And then I'm going to distribute 1/2 to 8, which puts us at a positive 4. On the right side, before I write it down, I notice that I can combine a couple like terms together just to save a step. 2x plus 1x would put me at 3x. And then I'll bring down the plus 4. I have variables on both sides of the equal sign. I'm going to move all my variables to the left. So I'm going to subtract 3x on both sides. On the left, 3x minus 3x cancels. I'm left with just 4. On the right, 3x minus 3x cancels, and I'm left with just 4. This is another equation where the variables completely cancel, but the two sides of the equal sign are equivalent. This would be an example with infinitely many solutions. With number 6, there are no grouping symbols, so it's not necessary to distribute, but I do notice that on both sides of the equal sign there are pieces that we could combine together. On the left, 12 and negative 8 can combine, so this will end up putting us at 4x plus 4. On the right, 2x plus 2x will combine, and this will leave us with 4x plus 3. I'm going to get all the variables to the same side of the equal sign, so I'm going to move those to the left. I'm going to subtract 4x on both sides. On the left, 4x minus 4x cancel, and we're left with 4. On the right, 4x minus 4x cancels, and we're left with 3. With this equation, there are no solutions because the variables completely canceled out and the two sides of the equal sign are not equivalent. All right, number 7, Anna was solving an equation. Her last line of work read 8 equals 8. What does this mean? It means that her variables canceled. And that both sides were equivalent. Leaving us with infinitely many solutions. Number 8, Tyler was solving an equation and his last line of work read -12 equals 12. What does this mean? So for Tyler, his variables canceled. The two sides of the equal sign are not equivalent. So there are no solutions. All right, I would say at this point, if you missed any of the pieces, because there's a lot of stuff that I stuck onto one slide here, I would go back and rewatch the parts that you need, or pause over certain areas so that you can fill in and get all the notes that you need for these 2 pages. For your practice pages, practice page 9 and 10 are the ones that go along with this topic. As you're doing these, just keep in mind that if your variables completely cancel out, you're looking for whether or not the 2 sides are equal or not equal. Also, as you're solving, if you find that you get one answer, kind of like the equations we've already been solving, that's okay too, because some of these can have one solution. Would recommend using pencil with these pages, just in case we decide later that there's some things that we need to tweak.